In today's session, I'll do a couple of things in the first half, and then in the second half, I'll give you an exercise. So I'll make sure I stop after 1 hour today, and I'll give you an exercise that you have to work on through the use of HPC. So I'll try to go slow. If you want to write any commands, you can write them, but I'm recording this video, so I'll share it quickly on the Google Drive so that you can access it and go to the commands, whatever works for you. Right. So first we'll have to log on. So as I said, the IP address for the HPC, we can try pinging CPU HPC. Well, it cannot resolve the host. So let's write 10.8.1.19. So we're getting a reply from that. Let's try GPU HPC as well. 10.8.1.20. So we're getting a reply from there as well. So it's working. And then we log on to the secure shell protocol. So our username and the IP address. Okay, so typically you will be provided with a password, a default password, but I recommend strongly that you change it as soon as you get your account and write the password somewhere for remembering. Okay, so now we are on the cluster. You can see it says my HPC username at N199, which is the head node for the CPU cluster. So if we do scl ---- list, so we can see the software collection utility gives us the Python 3.6 available here, and that is what we will be using. So we can simply enable this by scl enable. RH Python 36, and then we type bash. So it opens a new bash with Python 3.6 available. So we can check Python and then a tab. So you can see that Python 3.6 is now available to us. We can simply type Python 3 and that should work for us. So Python 3 opens and I can print something. So I can simply try an f string, which is available only in Python 3. Okay, so it works. If I do x equals 2 plus 2 in the curly braces, so it evaluates 2 plus 2 and it prints the value. And since it's a print as a function, it's working. So that means it's Python 3, because in Python 2 print was a command. That's the best way to check whether you're in Python 2 or 3. Anyways, let's do something more interesting with this. So next, what I already have done is to install a virtual environment. So for that, what we do is first we upgrade the pip available to us. I won't do it, but I'll just write the command. So pip3 install. Typically, that's what you do on your local machine. ---- upgrade, and then you type pip. But in this case, since we want the proxy to be available, so we'll try ---- proxy, and then you specify the HTTP proxy 10.8.0.1.88. So this should allow you to upgrade the version of pip. In my case, it's already upgraded, so it won't do anything. In your case, if you haven't done it already, it'll upgrade it for you. Okay, the next step is to upgrade the virtual environment. So in this case, we are not using venv, we are using virtual env. They are extremely similar. It's just that virtual env is the package manager for Python available in this software collection utility 3.6 Python that we have. So we'll upgrade it as well. Okay. The next thing is now that virtual environment and Python, the pip are both upgraded. By the way, sorry, we'll have to do both these things as a user. So typically what happens is if you do anything with pip, it will try to access the default path where Python is installed and try to do things there. But Python is installed in a path in /opt, which is a root folder. So we don't have access to modify things there. So if you type ---- user in a pip command, what it does is it will try to do everything that you do in terms of installing pip packages and so on into your home, and that is where you have access to write things and so on. Okay. So if you are not inside the virtual environment, you have to use a minus minus user, otherwise it may create problems for you. Um, and then once we have upgraded both pip and virtual and env in as a user, next is we create a virtual environment. So you type virtual env. Earlier, if you remember, we use the venv command. Okay, this time we are using virtual env, and we also in our desktops or laptops, what we did was we typed Python 3 with a minus m. Okay, this is simply to specify which version of Python you want to use when you are using virtual environment. If you do not specify that when creating a virtual environment, it will take the default version that's working for us. So in this case, it's Python 3.6. But in case you want to specify, you can specify the Python version as well as an option available in this. So you can check the manual and figure out. But in this case, if I don't specify anything, by default it will use Python 3.6, which is fine for me. And then we specify the path of the virtual environment. So I have a folder called virtual envs. That's just to package all the virtual environments. And I already have a test env available that I created for running things. So I won't do it, but if you want to have a test env, let's say 2, you can do that. And if you press enter, it will create a virtual environment for you, a new one that you can work with. Okay. So once the virtual environment is created, we will enable that. So we'll use source and this in the path. So in my case, I want to enable the initial one that I have created. So let's check. Let's do a pip list. So all these are available. So if I deactivate this and I enable the one that I just created, which was test env2, and then we do a pip list. See, it's only got 3 of these. There's no other environment available. There's no other package available. So we'll have to install things here. So in case I want to install something in this virtual environment, I have to do a pip 3 install, and then the name of the package, let's say numpy. And then since we require the proxy for the internet connection, we'll have to specify that. Oh, I'm sorry. Okay, so it's installed numpy now. So if we do a pip3 list now, it should, now this time it lists numpy as well. So it's quite easy to install packages in virtual. By the way, that video is available now. Okay, and we are recording this one as well. That's pretty much it. You can install as many packages as you want, as you require in your virtual environment. So basically now the framework is ready. All the packages we require are ready. Now we are ready to do something on the HPC. Till now we only have been installing Python packages. Let's deactivate this. Okay, so in this folder that I have for the demo files, there is a Python script that we want to run. So I already discussed this last time, but I'll briefly tell you. So it imports the NumPy package. This import is just to check if my Python package that I just installed is available. Okay, so this is purely to check if our virtual environment is working fine, because if you're not inside the virtual environment, then NumPy would not be available, because the default version of Python 3.6 that's given to us does not have NumPy available in it. And then we have two variables, two floating point variables, a and b. We simply print the values of those a and b and the sum in the f string format. So Python 3 is being checked here. And then I also print the value of pi from NumPy, just to make sure that NumPy is working fine for me. It's a very trivialized code, just to check the various features, and then you can do whatever you want with it. And then, as I said that we are on the head node, we can see that, am I the only, no, there are many people, it will show me. So a couple of people are there, and this time nobody is running anything. If I check the CPU usage, none of these is showing 100%. Okay, so I can quit with a Q here. And then what is not recommended is that you type Python 3 and you run the code here. But it won't run here right now. Just I wanted to show you that because NumPy is not available. The default version of Python that's available to me, Python 3, does not have NumPy in it. I'll have to activate. But again, you should not be doing this. But there's no harm in checking things on a very trivialized code. Don't run a full production code here, just to check things. Okay, so when we activate the virtual environment, if this time I type Python 3 followed by the code, this runs. So I'm happy that my virtual environment is working fine. If I enable this in my compute node, hopefully things should work fine. At least it should work fine on the head node to start with, just to check my virtual environment, nothing. I won't run any other code here. I'm happy with things working fine. So let's deactivate this virtual environment. And now what I'll do is, I have to write a PBS script. So let's look at the script briefly, run it, see the results, and then we'll go deep into the options available in the script and how to work with that. So the script is called script pbs python.sh. sh is for bash scripts. So let's open that. So we see what looks like some comments on the top, and then we have some commands. So let's understand the commands first, then we'll understand the comments on the top. So we do a cd followed by some environment variable. So this pbso work dir is an environment variable that's available to us when we run things on the cluster. So what it will do is, the current directory, the working directory, will automatically be, this $pbso work dir will return the path to the current working directory in the file system, and then you can go into that. Because it may happen that you are running the code from some other directory and so on, just to make sure that on the compute node you go into the right directory. So you go into this directory, and then it echoes something on the screen. It says running on, and then it prints the value of this another environment variable called PBS node file. So PBS node file, and the description of these things I'll show you. You don't need to remember these things. PBS node file contains the ID of the compute node on which the command was sent. Because you will have no control over that. You will have no prior knowledge as to which compute node will your job go to. But you will want to know where it went. And the way to know where it went is to use this environment variable, PBS node file, and it just prints. So cat is simply to print the contents of that environment variable. So it will print that on the screen, and you also want that to go into a file. So machines.list is a file it will generate, and you are redirecting the output of the environment variable PBS node file into the file machines.list. Okay, and then you print something else on the screen. Just some program output begins, and then you have to enable the virtual environment on the compute node. So for that, we'll write source followed by the um, executable for the virtual environment, and then once the environment is activated, we'll type the command Python followed by the script. In this case, the default version of Python is Python 3, so I don't need to write Python 3 because I installed the virtual environment in Python 3 only. So Python inside the virtual environment means Python 3. Is that clear? Machines.list is a file we are creating. So what we are doing is this file will contain the information about the compute node on which the job went to. I'll show you the results. Now on the top you see there are some comments. So typically if you run this bash script as it will not identify the comments. But what happens is if you send it to the queue manager through the queue sub command, then it tries to understand if these are comments or directives. So if you have hash followed by a PBS, that means it's a PBS directive. So the queue sub command will not ignore this, it will try to understand what's there followed by hash PBS. So it says minus q followed by a name serial. So there are various queues available on the cluster. In fact, if I go to the HPC website, right, so if I open the HPC website, is it working for you? Can somebody try please? Seems to dislike my browser. Let's try Chrome. Yeah, so if you go to the HPC website and we click the tab called list of queues, So it tells that there are certain queues available on the CPU cluster, and it will list all the queues. So if you use the qstat -q command, again I'll talk about this command in a bit of a detail later. So it will list down all the queues available. So we can see that this serial queue that I've used is available here. It has a total of 190 gigabytes of memory. It has a wall time of 1440 hours. And then when I ran the command, 25 jobs were running. Nothing was in the queue, and the limit was 20. Sometimes it can overrun the limit as well. Yeah. So this is typically what the queue details are. And if I go to the GPU cluster, then these are the queues available at the time when I ran the command. But if you want to check things, you should definitely check it yourself. So if I just come out of this script, so qstat -q, so it shows me all the queues available, and the serial queue is still available. Okay, so I can use this serial queue. Okay, so that's the first directive here. The second one is -o. I'll show you. There's a manual for this. It will have all the details in it. So the next is -o. So that is for output. So the output file, because there's no screen, there's no standard output like you have on your screen here if you run something on the bash. Here what happens is, since jobs are running on the compute node and you do not have access to the bash shell there, so what it does is all the output that was supposed to be displayed on the shell, standard output, goes into a file called out.o. And then if there is an error, the error gets redirected to a file called out.e. So if you open out.e after the job runs and there's nothing in it, that means there was no error. If there's something in it, so the first thing you will do is, if you don't get what you expected, is to check out.e. Then there is a name for this job, the PBS job that we have sent, because we may want to, I'm doing some sort of simulation. I want to run it for different parameter values. So I'll just give it a nice name, _1, _2, whatever, so that I can remember what sort of job is running where. In fact, there's something called dependencies. So one job's result may require the other job to run. So you can actually, in PBS, you can create dependencies also. So once the first job or whatever job has finished, the next job will automatically start. You don't have to wait or keep checking every time the job whether it's finished or not. So you can just run them all, but the ones which are dependent on the ones which have not completed will just stay on hold until the dependencies have finished running. Then we have a resource. So to specify the resource, we have a -l, a small l here. So that in this case, we need one node, that is one sort of computer, and with one core. So it's a serial job, so we only require one node and one core. So if you specify one node and two cores, it will try to find one machine which has a dual core or more higher processor. But if you specify two nodes and two cores, so it will give you two nodes, two cores each. So again, as we discuss parallelization, we'll talk more about what is the difference between these things. And then there's a -v command that I'll talk later. Okay, so these directives are there. On the top, we have this saying it's a bash script. There are different kinds of shells available. So this script, the commands here are working for bash. So this script is that clear? So let's run it now. So the way we run this script is to use the qsub command. So I simply say qsub. Yeah, it's available on the HPC website. So there's a question that are there templates available for this? So if you go to the HPC website and you look for useful scripts, these scripts are available. So it says all these files are available here. So there's a serial, it takes some time to load. There are files on Google Drive. So there's a serial script, there's an OpenMPI script, there is an OpenMPI with some, I think, multi-core jobs. So they have different template scripts available. You can pick up whichever you want and work with it. Some people use GPU, so CUDA script is also available. Some people use the software called Gaussian, so those scripts are also available and so on. And there are other pages as well. So if you look at submitting jobs, it will give you details of some more commands that are used inside the script. So for example, so this minus L with n CPUs 4 or proc shared. So there are many commands available. So please go through these things and they'll be helpful for you to understand things. And if you go to list of queues, so there's a page called job submission in detail. Well, this doesn't have much. Quick start to job submission. So here also it will have some more details on how to submit jobs and how to, so this is how you submit job, how to check what jobs are running, how to delete a job if you require, if you have put something on hold of the cluster had some problems, your job went on a hold, you can release the job with this command and so on. Okay. So all this is available. It's a bit unorganized, but everything is there. So just read through everything in your own time to understand what all stuff is available. So let's run this. If I type qsub followed by the script.sh, so as soon as I run it, it gives me a job ID. And then if I write, if I do an ls this time, it was a very small job, so it ran and the results were generated. If I do a qstat, then it shows the job ID, which is 380952, which was the job ID it created. So that was this recent job. And it says it took only 2 seconds to see if it is for complete, and it ran on the serial queue. Right? So good, my job worked. And it created 3 new files. So one was machines.list. So this is simply the file that was supposed to contain the ID of the node where the job ran. So the job ran on N127. So it shows me the path to that compute node. So in case things did not work or my output files could not be copied, like last time there was an issue with my account. So the output files could not be copied. So I know I have to go to N127 and find out the output files. But this time it worked. So let's look at out.e. So this is empty. So that means there was no error in this code. And if I look at out.o, we can see that it starts with running on. And remember, this was standard output, but it's all coming into it's redirected to out.o. So running on, and then again the ID of the compute node, program output begins, and then it prints the values of a, b, and a plus b, and then it also prints the value of np.py. So it means that numpy was working fine on the compute. So now if I'm happy with this dummy job, then I can now create a more complicated version of my code and run it with confidence. If you run the code directly and you don't really, and it takes some time to, the job to actually reach the queue and run, it took 1 hour, and then you get an error. So it's a 1 hour wasted. So you can do more interesting things. If you start with very simple check versions of code.
So if there is some code like which interacts with the user, like take some input, so can we do here?
It's not recommended. So if you want something to be supplied by the user, why would you do it on the HPC? You already know what you will supply later. So you supply that as a command and you modify your code, or there are ways to supply that in advance and then send. In fact, the assignment I have given will sort of use that. Okay. But it's not recommended you take input from the user when doing things on the HPC. We don't do things on the HPC interactively. I'll show you we can do that, but we don't tend to do it. Okay. And get out of the habit of supplying things on the terminal. Even if you're doing things, you supply things from a file. That's much quicker, because if you're doing things 20 times, at 20 times you have to specify 10 variables. This is school level programming where you take input from the user in the screen. If you need any input, take it from a file. Like Anaconda? Yeah, apt is not for Python, it is for Ubuntu. So this is a CentOS based, this is an apt is Debian based package manager. This is CentOS based. In CentOS, the equivalent of apt is yum, but again that is for the administrator. So when we say pip is for Python package manager. This is virtual environment is for Python packages. Apt is for a general sort of packages for the OS. So we don't allow you to modify the OS through package managers in Linux. If you want to really install some software other than Python packages, you will have to do it through configure and make. So basically build from the source code. But there's another way called Singularity containers that I briefly touched upon last time. So you can use that. That is much easier. So till now we are working with Python. Okay, so pip is working for us. Right, so we talked about how to log into the cluster. I showed you the directory structure. We prepared a virtual environment. We installed some packages, NumPy for example. I showed you the PBS script for running a Python code. We launched the script using qsub and we saw the output. And since there was no error, the out.e did not contain anything. And these are the commands in case you want to practice them, and they were already available on Moodle. So let's, should I go ahead or do you want to try these things first? Okay, so it's good. You try these things where the commands are there on the screen. So please try these things. Take your time and I'll move around if you have any questions. Yes, sir.
लास्ट टाइम मैंने HPC के लिए अप्लाई किया था टाइटल ब्रेक के लिए बट मैंने अभी एडिट किया